So for this one, we want to create the function cosine of x, and we want to pick the nice number to do the differential tangent line at, so that's 60 degrees, or pi over 3, and the dx is going to be negative 3 degrees, which we know is multiplying by pi over 180, so we get 3 pi over 180, or negative pi over 60. So let's go find the differential dy, which is the derivative, so negative sine of x dx, and plug in our numbers. So I get negative sine of pi over 3 times my negative pi over 60, so I know sine of pi over 3 is root 3 over 2, and in my pi over 60, so and the two negatives cancel, so I get a root 3 pi over 120. Now I'm going to put it together in my linearization. So my L of the 57 degrees, and that's the same as saying L of pi over 3, subtract the pi over 60, will give me f of a. Let me just kind of write plus your dy. So your f of a will be cosine of 60 degrees plus my dy. And cosine of 60 degrees, you know, is 1/2 root 3 pi over 120. All right, so this one here, to find the position, we want to find where it is at the beginning of time, which is time 0, and that's 0, and where it is at the end, which is 3, so I get 27 minus 27, so that's 0. So it starts and ends at the same place. So the other place we need to find is when the velocity is 0, and the velocity is 0 at... So factor a 3t out, and I get t minus 2 equals 0. So at time 0 and at time 2. So I need to find out where it's at time 2. So I put that in, I get 8 minus 12, so that's negative 4. So what the picture looks like here is 0. So it starts here at time 0. It goes back to negative 4 at time 2. And then at time 3, it comes back to 0. So here to here to here. So the total distance traveled will be 8. Okay, critical numbers. That's where the derivative equals 0 or doesn't exist. So I get secant squared of theta equals, just do the equal 0 first. So I get 4 equals secant squared of theta. So plus or minus 2 is equal to secant of theta, which means cosine of theta is plus or minus 1/2. So cosine of theta is 1/2, cosine of theta is negative 1/2, and we're just on 0 to 2 pi. So this gives me pi over 3 and 5 pi over 3, 5 pi over 3. This gives me 2 pi over 3 and 4 pi over 3. So when the derivative doesn't exist, so that's when the denominator would equal 0. So that would mean, so I'm looking at 4 minus secant squared of theta is the derivative, right? So when this is cosine squared, right? When this denominator is equal to 0, that would make the whole derivative not exist. So that would be when cosine is 0. But look at the original function. The original function has tangent in it, which is sine over cosine. Cosine can't equal 0, so those are ruled out because those would not be in the domain of the function. All right, so let's do one more, or two more here. So let's do angle of elevation. So we've got the sun shining over a 400-foot building, so that's the fixed number. And the shadow is coming here, so the angle of elevation of the sun is here. And this is the shadow length that's growing. And that's what they want me to find, is dx dt. That's what I'm finding. And I put the one fixed number in the picture. They tell me the angle of elevation is changing, so d theta dt is negative 0.25. It's decreasing. So I'm going to give it a negative. And the when information is when theta is pi over 6. So let's look at the equation that I can use for the trig function to get theta, x, and 400. So I'm thinking tangent of theta is 400 over x, and I don't like that as much as doing cotangent of theta is 1 over 400 times x. I'm even going to write it like that so I can see how easy it is to take the derivative. So I take the derivative, don't forget your d theta dt, carry along the 1 over 400, and remember the derivative of x is just dx dt. So now I'm ready to plug in my theta is pi over 6, so I think in terms of sines and cosines. So this is the same as saying sine of pi over 6 down here, which I know is 1/2. This is negative 0.25. Carry along this. And multiply, so I get negative 400 is dx over dt. Oh, positive, because these two negatives make a positive, and that makes sense because the length of x is growing. Okay, so let's do one more here. Let's do this derivative. So you know the derivative of arctangent is 1 over 1 plus the argument squared, and that's x cubed. Like I need to take the derivative of that right away, and I'm going to subtract. I'm going to be careful because I've got product rule going on. First d second plus second d first. Then you take the derivative over here, derivative of ln of stuff, 1 over stuff times the derivative of stuff. So I'm going to distribute this out to these two terms. I'm going to distribute the negatives. So I'm going to take an algebra step here. So I get 1 over x plus y prime over x plus y. I identify my y prime terms here and here. So I'm going to move this to the other side. So I get y prime over x plus y plus 3x squared y prime over, sorry. And, okay, can't erase. So I'm going to subtract this over. So I get 3x squared 1 plus x to the 6 plus 2xy cubed minus 1 over x plus y. So then to finish solving, I get 3x squared 1 plus x to the 6 plus 2xy cubed minus 1 over x plus y divided by 1 over x plus y plus 3x squared y equaling y prime.